everyone. So now it's time to begin our second session of the day with 11 crazy things Hanno didn't know he can do with Java. So I'm going to allow him to explain the title and actually run us through this presentation that I'm very curious about. Welcome, Hanno.
Yes, thank you, Anna. Very happy to be here. So my name is Hanno. I'm a Java developer and an Oracle ACE Pro and a Java champion. But that doesn't mean that I know everything about the Java language, right? In fact, back in 2021, I updated my Oracle Java certification, so the OCP certification. And this wasn't because I didn't do it before, because I had achieved a Java 5 certificate back when Java was part of the Sun family instead of the Oracle family. But still, my employer asked me to update it because we were participating in a bid for a project where we would provide a Java training for one of our customers for a few years to come. And they asked for all teachers to be Java certified for the most recent version. And I was like, sure, let's do the exam, right? I've done Java for over 14 years, at least back then. How hard can it be? Right? And I came across lots of things that I didn't know by heart. And I wrote them down as a list because I had to study them to pass the exam. And afterwards, I felt like it could be useful to compile them into a talk. So the 11 craziest ones, right? The 11 ones that I found most striking, I put in this conference talk. And it is not shameful in any way that I didn't remember them. Doesn't mean that I've been a lousy programmer for 14 years. It just probably means that these things about the Java language are not that well known, but can be worth learning about. And that means that this talk will be mostly showing code and live demoing stuff. In fact, I've got only 2 slides, the title one, right, and this one that just sums up where to find me and locate me. But the link at the top, I'll show them again at the end, but the link at the top is quite relevant because it leads you to the GitHub repository with the code that I'm using to show you all these demos. So if you're like, I want to play with this scenario or this example that Hanno presented, well, then you can feel free and go ahead to that GitHub page to see the code for yourself. That means that I'm leaving my slide deck now and I'm going to do the rest of the talk in my IDE right here. And the structure of the talk is quite simple. I've created a test suite of 11 JUnit tests that currently are mostly failing. And we just have to make sure that they will succeed at the end of the talk. And in order to make them succeed, we have to understand a few things about its concept. And I'll just run through them from 11 to 1 and show you the things that I didn't know after 14 years of Java development. This also means that you now get the chance to learn about all these things just in 25 minutes, right? So you'll learn these things about 300,000 times more quickly than I did because I took over 14 years. So it's a very unique opportunity for all of you. Let's start with number 11, a few freaky ways to declare and initialize arrays in Java. So I've created 2 tests here, and I'm asserting here that the array that is produced by this method has the size 2, but currently this assertion is failing. And we have to see why, or at least it's not failing, but I want to change something here, because in Java 11, a new feature was introduced called local type inference, and I thought let's then change this to var. What I didn't think about is that var actually isn't a type of array, right? It's a generic type that is inferred from the runtime type here, and that also means that you don't need the brackets. You just need var, and then it will work. A second freaky way of declaring arrays is the C-style array. This is a declaration that has been supported from the start in Java, meaning that you can declare an array with the square brackets after the variable name instead of after the data type here. But then when you declare them in a comma-separated list, it means that array 2 here isn't actually an array, but it is an int, and I cannot assign it to a new instance of an array. So that means that either I have to repeat the square brackets here, or, and this is the more sensible choice if you ask me, you just have to move the brackets to here and make sure that the C-style mechanism is not used anymore. I think this is more, people will recognize this style a bit better. I don't have the time to run every test again after I fix it, so I'll just try to fix them all in one go, and afterwards I'll run the entire test suite and fingers crossed that they all become succeeding, right? That they all become green. Number 10 is about stream elements. So the stream APA in Java has a method called sorted. And in this case, we are creating a stream of a few talks. This is just a very simple Java class that has a speaker, a title, and a specific time where the talk starts. So these are about the Looney Tunes characters, and they talk about all kinds of stuff that they think is important. So Bugs Bunny is talking about carrots, and Tweety is talking about banning all cats off the internet, which is a very bad idea, in my opinion, because cat pictures is one of the main reasons the internet exists, right? And when we run this test assertion, it gives a very cryptic message. It says class cast exception, the class talk cannot be cast to Java long comparable. Well, in this case, this happens because the sorted method, and actually the Java doc states this, the sorted method wants all the elements of the stream to be comparable. If they're not comparable, a class cast exception is thrown. So in order to make this code work, I just have to go to the talk class and make it implement comparable like this. And oops, implement the methods. In this case, it is compared to, and we can, for example, compare them by title. And if we do that, the stream elements will have become comparable and we can actually sort them. Number 9 is about static interface methods, which can be a lot harder than you might think. So I have created an interface called slot. This is a conference slot, and there's a static, obviously, it's always implicitly static in an interface, a static variable called length in minutes, and there's a static method called length description. And there's a class talk that implements this interface, right? Well, in the test, I'm referring to this static int here just by the variable name, and that is no problem with static variables. But when I want to refer to this static method in the interface here, I cannot use the same mechanism. I cannot use the variable name. So I was like, well, of course, then we have to use the class name, but also that is not allowed in Java. The only thing that I can do here is actually refer to the actual interface name. We'll continue then. I think we have fixed number 9 adequately. Actually, the assertion wasn't failing at all, so we have fixed it nonetheless. Number 8 is about anonymous subclasses in enums, because that is possible. I never knew about that, but it is. So these test assertions are about Java conferences. One of my favorites, DevOps in Poland, DevNexus in Atlanta in the US, and of course my home conference, JFL in the Netherlands. And the assertions here want a specific string to be produced, and it's always the same format, except with JFL, because JFL has been called by other people, not necessarily by me, the best one-day Java conference they knew. And in this case, we want to assert that for JFL, a different string is produced. But as you can see, this assertion is currently failing because it uses the generic string here. And if we go to the implementation and see what the code produces, it is because this is the method that just produces the same string for every constant of the enum here. Well, we can change the behavior if you want by creating an anonymous subclass here and overriding the method when it's the next, right? And then we can just copy the text here that we want it to be added and append it here. So this was in one of the practice exam questions, and I didn't know that it was possible. So I selected the answer, this will not compile, but actually it is possible, right? And I never knew about it. So an enum constant can have an anonymous subclass in it, and where you can override the method that is the same for all the other enum constants, but for this constant, it is a bit different. So that is very cool. Number 7 is about division by 0. Now, I have always learned that you cannot divide by 0, not in mathematics and also not in Java. I have created 3 methods that try this. So they divide int primitives, float primitives, and double primitives. And then I assert in the test that an arithmetic exception is thrown. Well, as you can see here in the assertions, the only assertion that is correct is divide int. So divide int actually throws an arithmetic exception. when you try to divide by 0. But with floats and doubles, something else is happening entirely. Actually, this assertion is all wrong. What we should do is assert that number 7 division by 0 divide is equal to a certain constant. And in this case, it should be float dot positive infinity. So there's a specific constant in the float wrapper class and also in the double wrapper class that reserves a specific value for calculations like this one. And that means that the float primitive and the float double actually will not throw these arithmetic exceptions. So in this case, we just have to change our assertions to mirror the actual behavior, and probably then we'll see at the end of the talk, these tests will pass. Number 6 is about method overloading priorities. The title here says they are all over the place. Well, actually, they're pretty well defined and very easy to reason about once you know how they work, right? But when I learned for the exam, studied for the exam, I didn't know everything about it. So in this case, we've got a class that has 3 overloads of the print sum method. One expects integer wrapper classes, one expects double primitives, and one expects an int var arc parameter. When we call this method, we actually expect I expected that when we pass it an int, let's see here, that it would end up in this one, because I thought the integer wrapper class is kind of similar to the int. But actually, Java prefers widening over boxing. So it widens the int parameters we pass to print sum to doubles and picks out this method. And by the way, our IDE is already giving it away because this method is in different color font because it is called and these ones are not called, right? So the IDE is giving us hints here. There's another reason why it works like this, and that is because of backwards compatibility, right? So widening in Java, widening ints to doubles has been supported for a very long time, but boxing an int to a wrapper type was introduced in Java 5 in a later Java version. So that also means that the oldest behavior is preferred here, and then afterwards it checks wrapper types for newer features. And also, this is for performance reasons, because widening is a much cheaper operation in Java than boxing, or the worst one, creating a var arc parameter, because that involves creating an array. And of course, if I would comment this one out, then it would prefer boxing because it's a bit less performance heavy than creating an array. And finally, of course, when only a single definition remains, then it will call the print sum. So to fix these assertions, we should not leave the one that is actually correct, and remove the assertions that in the end don't make sense. And then we come to number 5, the crazy stuff that is allowed in switch statements. I have created a switch statement that generates a description, a string based on a rating, right? So imagine you would rate my talk afterwards and you could give it an A, which means it's a great talk, a B, which is a good talk, C or D, an average talk, and E or F, a bad talk, right? And the assertions here come from a parameterized test. So A should be linked to great, B to good, C and D to average, E and F to bad. But a strange thing is happening here because C and D are not yielding average, they are yielding bad talk. So what is happening here? Well, this was actually one of the practice exam questions, and I just assumed that this meant or, but of course this doesn't work that way. This is a bitwise or operator, and that means that if you do a bitwise or on a C and a D, you actually end up with 103, which is a G in character data types. So we're actually checking G here, and that means that the C and D values fall through to the default one. So this is a very tricky one, and in order to fix it, we would just introduce a separate case for D and use the fall through like this. And then it would yield average talk again. And that is what we want. So then we get to number 4, equality when dealing with cloned arrays. I've created an array of talks here. And actually, these are also This is also a tip for later in the program. So this is the talk you're attending right now. But I thought the talk by Rishi Mitra on JSON relational duality looks very interesting. So I included it here in my talks array. So be sure to check that one out because it looks like that is going to be a blast. Now this array right here contains two elements of talks, and we can simply get it, but we can also get a cloned version of it. And in my test assertions, initially I assumed that they would be equal to each other. But of course, when you think about it, a cloned version of a reference to an array will obviously be not the same instance. So we have to change this assertion to false. And then I thought, does it also mean that the actual elements inside the talk, will they be cloned or will they be the same? Actually, when you think about it, or when you research it, the array clone feature means that it's a shallow clone. So only a new reference is created, but the elements that were in the original array still exist and actually are referred to by the new reference. So that means we should change this assertion to contains, because it actually contains all the other talks. And then we get to number 3, wrapper objects. So as you may know, Java has primitives like int, lowercase I, and wrapper object counterparts like integer, uppercase I. I have created a method here that I called integer equals, but it performs the double equals sign operator, right? So it checks if they are the same instance, integer A and integer B. Well, just for a quick sanity check, if we compare 200 to 300, then they should not be equal, they should return false. And this assertion is actually passing. So the sanity checks out. However, you probably remember that in Java, all wrapper objects are immutable. So when you have an integer wrapper object that is called I, and you perform an I++ on it, what actually happens is something like this, right? An integer value of I.int value. And this is because the integer wrapper object, and all wrapper objects for that matter, are immutable. So you can never set a value of an integer wrapper object. Instead, an entirely new integer is created. That also means that an integer of 200 and an integer of 200 wrapper objects can never be equal to each other. So we assert here that when we pass the same arguments, it should return false. And this is also true. However, when I came to this example in the practice exams, I really lost my mind. I lost it because we are comparing 10 to 10, and it doesn't return false, it returns true. Whereas when we passed 200 and 200, it did return false. So what is wrong with the world is what I thought. And then I researched it a bit, and it turns out that to save on memory, Java reuses all the wrapper objects whose values fall in a certain range. And for short and integers relevant to our test case, this is the range between -128 and +127. And because 10 falls in that range, the instances are reused to save on memory. So the double equals operator will then always return true when it's within that range. And by the way, this also holds true for booleans and bytes and certain character values. So that was definitely a fact on Java that I didn't know before I did certification. Okay, we're nearing the finish line. We're getting to number 2, and this one is about functional interfaces. You might recall them being added in Java version 8. So in the Java 11 certification, they were quite prominent. And lots of questions were about what is a functional interface, and when are there functional interfaces, and when they were not. So just for sanity again, is an abstract class with a single abstract method a functional interface? And then Java says no, because it should be actually an interface. Okay, fair enough. So this is the classic functional interface, right? An interface speaker with a single abstract void speak. I could target this with a lambda expression of type runnable, for example. Then if we introduce a functional interface called batch, is it a functional interface? Well, in this case, it is, because it has an abstract method print, and it has a second method called flip, but it has a default implementation. So this is not an abstract method. So this one still has a single abstract method, and you can use it as target for your lambdas. Now I've created an interface ignite speaker. Very short talks, right? So we add a method called stress out over time limit. but this interface extends the speaker interface. And if I want to make this a functional interface, I can't, because multiple abstract methods have been found here. The first one is, of course, speak from the super interface, and the second one is the one we add right here. And Java doesn't know what abstract method should be targeted for your lambdas, so it doesn't allow you to make this a functional interface. So I thought, let's try that again, create an interface called Lightning Speakers, also a very short type of talk, but this time I've overridden the speak method from the speaker interface with a default implementation. And now the Lightning Speaker class still has a single abstract method called stress out over time limit, and I can target this using a lambda expression just fine. Okay, and this is the final one, and I really lost it here again because I thought the interface room has 3 abstract methods that can never be a functional interface. But as you can see, this is a valid functional interface. And there's a very specific reason for it. Java sees this method as the single abstract one, and then says, I see here that you are redefining the equals method from object, and you are redefining the toString method from object. Well, that's all fine and dandy. You're just redefining them from the object class. And because everything in Java is an object, this is perfectly valid code. In other words, if you target this functional interface with a lambda, Java says, I know you probably don't mean the equals method because that is from object, and you probably also don't mean the toString method. So let's just use the book method. So these 2 methods that originate from object do not count towards the single abstract method limit. And I only learned that when I updated my Java certification. Right, let's get to the final one here. Passing arguments to method references. When I studied Java 8 for the first time, I really liked method references, but I never used them very much with constructors. And I'm going to explain to you why. I'm creating new venues here, and this constructor has a few overloads. There's a default one, there's one that takes a string, one that takes an int, and there's one that takes both of them, a string and an int, right? And I can create new venues in the regular way just fine. I also can create them using lambda expressions like this. And you can already see that my IDE wants me to use a method reference here. So I did, right? I used the method reference and it works just fine. But then I wanted to call the overload with the string parameter. And I always kind of switched back to lambdas because I never knew how to target the string overload. Oh, if you think about it and research it for a bit, if you use this constructor reference, you just simply say, get me the constructor reference of the constructor that does not take any argument. And that is expressed in this functional interface target type here, supplier. What if we would want to target the constructor that takes a string argument? Well, and then we could, instead of a supplier, use a function that takes a string and a value. And now we are targeting one of the overloads of the constructor. And that means we should use apply instead of get and pass the parameter value here. And the same thing we could do here by changing this to a function and putting integer right there and value. And call apply here again, apply, but then with the value of 200. And finally, if we want to use the most extensive constructor here, that takes 2 arguments, so we could use a by function that takes, again, a string, integer, and the return time is venue here. Let's call it again with classroom and 30. This is just one of those facts that never occurred to me when I started using Java 8, but I learned it during the certification, and I really like that. And the fact that I could learn it that way. So moment of truth, let's rerun all the tests, see if I made any mistakes or if I did it correctly. I see one of the tests is still failing, so let's see if I can quickly fix that. This is just an assertion that I forgot to change up. When I learned about the behavior of savoring on memory and reusing the wrapper objects, running them again, and I see that all the tests are passing, so that means that we have learned 11 crazy things about Java. that I hope you didn't know before, and now you do. Want to come back to my earlier remark. If you like these examples, you can find them here on GitHub, so follow the link there. If you're interested in one of these subjects, I actually, a while ago, wrote a blog post about all of these, and I added some more details there, so you can use that link to my website to read up about one of these topics a bit more. And yeah, if you'd like to talk, let's keep in touch. And if you've got any questions, feel free to ask them in the chat or find me afterwards somewhere online. Thank you for your attention, and I'm wishing you a very pleasant virtual conference day. Thank you.